Hey, today we're going to talk about solubility, and we're going to actually determine how to find out whether an ion is soluble or insoluble. Before that, you need your reference tables today. Absolutely, so I will pause. Okay. Now, we're going to open up to page number 2, and we're going to open up to table F. And table F looks something like this. So if you look, we have ions that are soluble and ions that are insoluble. So this is soluble, this is the exception. Then we have insoluble, and then this is the exception. What I want you to do right now is get out a color pencil, crayon, marker, whatever. And I want you to put a green dot here. And I want you to put a green dot here. And then we're going to put red dots here and a red dot here. So what does this mean? Basically, all you really need to think about is if it falls in this column or in this column, it is soluble. For example, right here at the top, you'll see group 1 ions. Lithium, sodium, potassium, anything that contains a group 1 ion is always soluble. And you see there's no exception for it. There's also no exception for ammonium. So if anything contains ammonium, always soluble. Nitrate, acetate, or hydrogen carbonate, or chlorate. Always soluble. So if you see that, that is automatically always soluble. Now when we look down at a halide just means a group 17 element. So fluorine, chlorine, bromine, iodine, acetate. So halides are normally soluble, except when it's silver chloride, lead 2 chloride, or mercury, dimercury chloride. Again, if it's silver chloride, it is insoluble. So AgCl, silver chloride, silver iodide, silver bromide, silver fluoride, insoluble. If it is lead, Pb2Cl2, right? PbCl2. If it is lead chloride, also if it's dimercury chloride, it is also insoluble. So because they're an exception, that makes them insoluble. Now when you look over here, anything that contains hydroxide is normally insoluble, which means it won't dissolve in water. You'll have little tiny clumps once you stir it up and dissolve it, or it will settle back down to the bottom, much like sand and water. Now if you have sodium hydroxide, sodium hydroxide is normally insoluble. So if we're talking NaOH, normally it's insoluble. However, when you combine it with group 1, so there's 2 different ways you can look at it. You can automatically determine that it's a group 1, so it's always soluble. Or you can look and see that it is one of the exceptions, because all of these exceptions says when combined with the group 1 ion or with ammonium. And a couple other ones. So for example, if you had calcium hydroxide, it's actually soluble because it is in the exception column. Okay? So pay attention to this information. If you put the dots there, it'll make it so much easier, because this is something that either you get or you don't get, and it's one of those things that you need to work at. So I have right here, this is filter paper, and we use this during our Botanicurus lab when we were looking at species X, Y, and Z, and it soaked up all the dye. But the way that this works is you put this into a funnel, and this filter paper, you can use it to separate solutions. But you can only use filters to separate solutions where they're insoluble. Because if you have a reaction and you have something that is insoluble, whether it's an exception over here or whether it's just straight up insoluble, you're going to have the powder is going to be left on your filter paper. And that's because it doesn't form a soluble solution. It doesn't form an actual solution. So it will be left in powder form and it will be a solid on your filter paper. You're going to see some questions like that in the practice problems. Speaking of which, look right here.